Hi everyone, today we are going to start 1.6, which is the last section of chapter 1, classify polygons. A polygon. A polygon is a closed plane figure. It is formed by 3 or more line segments called sides. Each side intersects exactly 2 sides, one at each endpoint. Vertex. Vertex is the endpoints of the sides. There are 2 different types of polygon. Concave, which means the figure kind of goes in. Or convex, which means it's more of a rounder figure. I kind of always remember concave as the word cave because a cave indents. So anytime a polygon indents, think concave. If it's more round and there's nothing that it doesn't look funky, it's convex. Here's another way you can kind of decide if a figure is convex versus concave. If you draw lines around it and it does not go in the interior of the polygon, it's convex. If you do draw a line and your line goes through the interior, it's concave. All right, so tell whether the figure is a polygon and whether it is convex or concave. So let's look at A here. Is this a polygon, yes or no? The answer is no. Now you might be wondering why. The reason is because of this segment right here. That segment is inside the interior of the polygon. You cannot have that. So you have segments that intersect more than 2 segments. Cannot be a polygon. Let's go to B. Is this a polygon, yes or no? The answer here is yes. Now, what type of polygon is it? Convex or concave? It's convex. There's no indents. C. Is this figure a polygon, yes or no? The answer is no. Why? This part right here. That is not a segment, it's not a straight line, so we have a curve, and curves are not included in polygons. D, is this a polygon, yes or no? The answer is yes. And what type? Convex or concave? It is concave. And we see that because of these indents here, 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 and here. All right, let's try this again. Tell whether the polygon, or tell whether the figure is a polygon, and if it is a polygon, convex or concave. So for the first example, it is a polygon, and it's a concave. So we have segments, straight segments, but we do have an indent, which means concave. Number 4, is it a polygon? No, because of this curvature here. 5, is it a polygon? Yes. And what type? It would be a convex. And then finally, is this a polygon? The answer is no. And the reason being is that those segments end up colliding, crashing, going through each other, and polygons cannot have that. Classifying polygon. A polygon is named by the number of its sides. This is something that you will have to memorize. So a 3-sided polygon is a triangle. A 4-sided polygon is a quadrilateral. 5-sided is a pentagon. 6-sided is a hexagon. 7-sided is a heptagon. 8-sided is a octagon. A 9-sided is a nonagon. And a 10-sided is a decagon. 3 through 10 is where you should definitely know the names. Anything above 10, I'm not going to quiz you or test you over, but a 12-sided polygon is called a dodecagon. And then anything above 12 is you just kind of use the name. So a 13-sided polygon would be a 13-gon. A 20-sided polygon would be a 20-gon. So you kind of follow that pattern. Equilateral. Equilateral means all sides of the polygon are congruent. Equiangular. Equiangular means all angles in a polygon are congruent. And a regular polygon is a convex polygon with both congruent sides and congruent angles. So here are some examples of regular polygons and what they look like. So a triangle is a regular polygon. A square would be a 4-sided polygon. That's what a pentagon would look like as a regular pentagon, a regular hexagon, and so on and so forth. So you'll see as you get more sides, they look more like a circle. Each sign suggests a polygon. Classify the polygon by the number of sides. Then tell whether it appears to be equilateral, equiangular, or regular. So for our first problem here, we have a triangle because there's 3 sides. And it would be a regular polygon because the angles and the sides are congruent. Classify the polygon by the number of sides. It would be a quadrilateral. I'm just going to put quad. And we see that the sides are not congruent, but the angles are, so it would be equiangular. We have a stop sign, and there are 8 sides, so it's an octagon. And we see that the sides are the same and the angles are congruent, so it's a regular octagon. I'm just going to put reg. And then for the last one here, even though technically this isn't a polygon because it collides, let's kind of focus on the outside, how it makes an X here. And so you have to count the number of sides. So count them and tell me what type of polygon do we have here? Well, it's a dodecagon. Has 12 sides. And then is it equilateral, equiangular, or regular? This is actually a trick question. It's none. The reason being is that the sides aren't the same. Our angles also aren't the same. We do have right angles here, but we also have like angles like that, so it's none. Now I do have a few more examples here, but I'm actually going to skip those for right now. If you want me to go over those individually, I can with you, but for this lesson, I'm just going to skip those. All right. A table is shaped like a regular hexagon. The expression shown represents the side lengths of the hexagonal table. Find the lengths of the side. Well, we know that we have a regular hexagon. What does regular mean? It means that the sides are congruent and the angles are congruent. So we have side lengths here. So since it's regular, I know that those sides are equal to each other. So I'm going to set this equation up as 3x plus 6 is equal to 4x minus 2. I'm going to subtract 3x from each side. So I get 6 is equal to x minus 2. I'm going to add 2. So 8 is equal to x. But we wanted to find the side length, so I need to plug it back into our equation. So if I do 3 times 8 plus 6, and I plug that right in my calculator, I get 30. And I can double check with the other side length, and if you do so, you'll also get 30, which is good because they should be the same. Last problem here. Each figure is a regular polygon. The expressions are given for two side lengths. Find the value of x. So regular figure, these are congruent. All right, so I'm going to set my equation up as x squared plus x is equal to x squared plus 4. Oh no, I have these x squareds, and they look a little scary. However, if you have one thing on the equal sign that's the same as something on the other side, what happens? Well, they cancel out. So if I subtract x squared from each side, my x squareds are gone. And what am I left with? X is equal to 4. Now it just asks for the value of x. I found it, and I'm done.